Alright, welcome to day 17 of, day 17, bro. Stop playing. Grind don't stop. Almost there to a month, But let me just double check. I think day 17, yeah. It's gotta be. Yes, sir. Day 17, and we're gonna do the same thing. Boot.dev, learning some Go. After this, I might do a project, but there's like a lot. Holy crap. Maybe I'll do half today, but I don't know. I do need to know this for sure because like I understand it a little bit, but arrays and like strings is a little different in Go that I'm kind of used to in other languages, like more higher level languages like Python, and even it's a little different from C. I think just a little bit. It has a C influence, but I think it's a little different when it comes to strings. But I don't know. We'll see. I'll figure it out today as I'm recording. But yeah, here's my typing skills. You like want to see my typing skills? I'm so washed. Oh no. Yeah, I'm washed. I use that little the corn keyboard. Corn keyboard. And I've been loving it because I think it corrected my typing, which is really nice. So, yeah, not 100 yet. I'm still trash at typing, but it's okay. As long as Vim is fun for me, that's all that matters for me. Anyways, let's lock in real quick. Let's get this running. Maybe I'll just do half today, and then maybe I'll do the rest on my own, and I'll do. So yeah. Anyways, so arrays are fixed size groups of variables of the same type. For example, is an array of size 4 of type string to declare any array of 10 integers. When our clients don't respond to a message, the two additional complete the get message with retries function. It takes 3 strings and returns an array of 3 strings and 3 integers. Okay. The return string and array contains the original message. The first is the primary message, the second is the first reminder, and the third is the last reminder. The integers in the array represent the cost of each message. Is equal to the length of the message plus the length of any previous messages. For example, hello costs $5, world costs $5. Okay. Plus the length of any previous messages. Okay. I think I get it. So we have a string. Okay, so I can just return a message, the size, which should be 3, string, and primary, secondary, territory. Territory, like this. We return messages. And cost per message, size 3 of integers, length of primary, length of primary plus secondary, I think we just take literally everything primary. Secondary. This is a valid way to... This is so trash. What am I missing? What am I missing here? I'm not... What? Oh. What? What am I missing? What? Cost per message. Okay. I'm missing something. I don't know what I'm... Oh. No. Alright, so I can run it now. Okay, next. Slicing goal. 99 times you will use slice into the array when working with an order list. Arrays are fixed in size. Once you make an array of 10, you can't add an 11th element. Yeah, basic computer science stuff here. Not dynamically sized. Flex view of elements of an array. The value of a slice is nil. Non-slices are always have underlying array, although it isn't specified specifically to create a slice on top of array. We can do. One free retry message while pro members get an unlimited amount. Retries are a premium feature now. Get message with free retries for plan function. It takes a plan variable as input as an array of 3 messages. You've been provided with constant representing the plan types on top of the file. If the plan is pro, return all the strings from the messages input in a slice. If the plan is free, return the first 2 strings from the message input. If the isn't either of those, return a nil slice. And let's do a switch statement. Man, I'm gonna do a switch statement. Oops. So I'm returning a string, an error. Since we're throwing an error, we definitely need to import the import f10t. Oh, let's use the error package actually. Errors. Let's also do plan string. Okay. So wait, so what kind of, is it a string? Plan. Okay. So if plan, so the switch. Case equals free. Return case pro. Return. Okay, if it's free, this is a pro actually. Okay. I think okay, so all I gotta do is, if it's a propan, return all the strings from the message in a slice. Okay. So we could just say message. Like this. And now free returns the first two. Zero to, oh, actually would have won. Unsupported. Oh no. I think it's this one. Exclusive. Okay, so two. Okay, we're good. Next. More slices.
In the world of programming, we have way too many names for ordered lists of things. In JavaScript, we call them arrays. In Python, we call them lists. Well, in Go, there's actually two unique types: arrays and slices, and they work very differently. And in this video, I'm going to break down exactly how they work and when you should use each. So we've talked about how arrays are fixed in size, and you might be wondering, well, that's not very useful.
I like his videos.
Why would I care about an ordered?
I think he goes a bit beyond the typical explanation of a array. Like I could see more of a language application, which I kind of appreciate.
Of things if I can't even add to or remove from the list. Well, that's where slices come into play. So let's draw out a simple array. I'll do it in yellow. Let's just say it's storing some numbers. We might have some numbers like 6, 3, 2, 6, 5. And I'll draw the indices. Let's do that in pink. So the index of the first item is 0, and then 1, 2, 3, 4, right? And the size of the array is 5, which in Go we would write like this. We would say we have an array of 5 items, and they are integers. Okay, cool. So we understand what an array is, but what's a slice? Well, slices in Go are written with this syntax: open close bracket, int. And you'll notice that the size is missing. Okay, so a slice is a dynamically sized, flexible view into an array. So slices are built on top of arrays. So that means, for example, that I could create a slice that just looks at this kind of middle portion of this array. If I were to write this in code, I would basically say if this array is named A, so A is this yellow array here, if I want to create a slice on top of that array, then I could write B colon equals A from, we're using square brackets here, index 1 up to, but not including, index 4. Okay, so the first number is inclusive, the second number is exclusive. And now B is this slice of kind of just that middle view of the array. And here's the important thing to understand. In Go, we actually almost never deal with arrays directly. 99 times out of 100, you'll just be working with slices because slices provide a much better developer experience. They're built on top of arrays for kind of memory management reasons, which we'll talk about in just a second. But you really want to be working, for the most part, with slices because you don't have to worry about that fixed size problem. Let's talk about how slices work, kind of specifically how they work in relation to your computer's hardware or your computer's RAM. Now, RAM just stands for random access memory. It's where variables are stored. The best way to think about RAM is just a mapping of addresses, so address, to data, right? It gives us a place to store stuff. So, for example, at address 0, we might have some data that represents, I don't know, the number 4, right? And then at address 1, we might have some data representing the number 5. I don't know. I'm just making stuff up. But you get the idea. We have addresses, and we have data associated with that address. Slices and the arrays that they are built on top of are stored in contiguous memory. Basically, what that means is a slice or an array is an address in memory where the slice or array starts. So, for example, at address 0, we might say this is the start of a slice. And the slice actually continues for the next, several kind of bytes of data. Let's say that it's a slice of length 3, so it actually would reach across all 3 of these addresses. So if you have an array or a slice and writing 15, I'm going to have to do all of this array management manually, but it's important to understand that this is what's going on, then we'll never have this overwriting problem. Addresses in memory, your slice or array will use. Now, this is primarily important for performance. Because all of the data is stored next to each other in memory, it's going to be faster to kind of iterate over all of the values in our slice. If we stored each index in kind of random places in memory, it would take a lot longer to go collect all of that data just, from a hardware perspective. However, there is a downside to having to store all of our memory kind of next to each other. Let's pretend that we have this slice or this array that starts at address 0 and has a length of 3. So it's using kind of these 3 addresses in memory, or these 3 bytes of memory. And let's say here at address 3, we're storing a different value. Maybe we're just storing, I don't know, the number 6. But this is a different variable. This is some other variable. The problem is, if we want to expand our slice, say add another value to it, we're going to run into the next thing in physical memory. That's a huge problem. We don't want to overwrite some other variable just because we're growing our slice. So this is why arrays are fixed in size. If we just can't grow them, then we'll never have this overwriting problem. So the question, of course, is how do slices do it, right? Well, slices are built on top of arrays, and basically what happens is, I can draw this out for us. When we want to grow a slice whose underlying array has run out of room, right? So we have our slice built on top of this length 3 array, and we want to grow it into a length of 4. What happens under the hood, and this all kind of happens without you seeing it as a developer. You'll see later when we get to the syntax, it's actually really simple. What happens is this data is copied into a new location in memory. So we just take this 4, we put it over here, 5 over here. Actually, I'm going to use the same colors. That would probably be easier to understand. So 4 comes over here, 5 comes over here, 3 comes over here. And then let's say that we know we want to grow our slice significantly. So the new underlying array, let's say, we'll have a length of 6 now. So it had 3 here. Now the new array has pre-allocated, right? We've essentially reserved memory for up to 6 spaces. Let me draw all of that out. Cool. And these addresses over here are going to be totally different, right? Maybe it's address 15, address 16, 17, 18, 19, and 20. Cool. So all the data from the old array gets copied over, and now we're able to expand our slice to a length of 4. Right? So here our slice was length 3 and the underlying array was length 3. Now we've copied over the data. We've created a much larger underlying array, and now we have a slice of length 4. Maybe we wanted to append, say, the number 2 to the end of the slice. So again, as the developer, you're not going to have to do all of this array management manually, but it's important to understand that this is what's going on under the hood because it has performance implications. Copying data isn't super efficient. If you're copying data from one section in memory to another over and over and over again, it can slow down your programs.
Great insight. I like it. Slices wrap arrays to give a more general and powerful and convenient interface to sequences of data, except for items with explicit dimensions such as transformation matrices. Most array programming Go is done with slices rather than simple arrays. Slices hold reference to an underlying array, and if you assign one slice to another, both refer to the same array. If a function takes a slice argument, any change is to the elements of slice will be visible to the caller, analogous to it passing a pointer to the underlying array. A read function therefore accepts a slice argument rather than a pointer and a count. The length which within the slice sets up an upper limit of how much the data to read. Here's a signature of the read method of the file type in PackageOS. Okay.
In the world of...
I like this. Very good stuff. So we don't need to think about the underlying slices of a array of a slice. We can create a new slice using the make function. Okay. Alright. The capacity argument is usually omitted and defaults to length. Slices created with make will be filled with the 0 value of the type. If you create a slice with a specific set of values, we can use a slice literal. If you did, then it would array instead of a slice. The length of a slice is simply the number of elements it contains. It is accessed using in the built-in. The capacity of a slice is the number of elements in the underlying array, counting from the first element in the slice. It is accessed using in the built-in cap function. Unless you're hyper-optimizing the memory usage of your code, you don't need to worry about the capacity of a slice because it will normally grow as needed. We need a lot of text messages as text I/O and our app is getting slow and responsive. If we know the rough size of a slice before we fill it up, by creating the slice with that size ahead of time so that Go doesn't need to continuously allocate new underlying arrays of larger and larger sizes. By setting the length, the slice can be resized later, but we can still avoid all expensive resizes since we know what we'll need. Complete the get message calls function. It takes a slice of messages and returns a slice of message calls. Pre-allocate a slice for message calls of the same length as messages slice. Return the call slice with cost for each message. The cost in the call slice should correspond to the message in the message slice at the same index. The cost of a message and the length of the message multiplied by 0.01. Okay. Data type, house size, and the capacity. Oops. It takes a slice of messages and returns a slice of message costs. Okay. So message cost. Should I just append? Truncated to int. What are you talking about? Is that good? Y 0.01 untyped float constant truncate. Bro, do I gotta convert this to float 64? No way. Why is this not a valid way to do it? What? You can't multiply. I guess into float then. Into float. Go. Okay then, yeah, float 60, 64. The first argument must append to. First argument to append must be a slice. Oh, I see. I got it. Message. Yeah, I remember this. You can just go like this, right? Wait, so this is not do automatically, or do I have to? Man. Alright, let's test it out. Oh, I failed everything. Message cost? Yeah. I don't know why. That's weird. I think I'm missing. Doing something wrong here. Fill cost slices with costs for each message. The cost of the slice should be correspond to the message in the message slice at the same index. Is this not how to like? Can we not iterate? Expecting that my actual was a bunch of these. I thought by default it does this. Where is this stuff like even? Default, yeah. Interesting. I'm getting like really big. A really big. Oh, I'm appending. Duh. Can I just do this instead? Bro, my logic was stupid. Awesome. Alright. Next. Holy crap. Length of a slice may be changed as long as it fits within the limits of the underlying array. The capacity of a slice accessed by the built-in function cap reports the maximum length the slice may assume. Here's a function to append data to a slice. If the data exceeds the capacity, the slice is reallocated. The resulting slice is returned. The function uses the fact that length and cap are legal when applied to the nil slice and returns 0. Interesting stuff. All right. What is this? Veridic. Veridic. I don't know what that is. This is accomplished using the ... syntax and the function signature. Veridic. How does he pronounce this word? Okay. This is like you can print in an infinite amount of we need to sum up the cost of all individual messages so we can send an end of bill month to our customer, include the sum function. I'm still confused on what this is to say. So we can, is this arbitrary number of final arguments? This is accomplished using the okay. I see. It just combines everything together. Okay. So this is taking anything and you could pass in slices using the ... So what do we do? Okay, so return. So for I. All right. Let me challenge myself a little. Okay, what was the better syntax for this? I think it was like for I in range. It was for is it the right syntax? Okay, I'm not. Let me see the range syntax. Range syntax. Oh, okay. Like that. Okay, I remember now. Okay, yeah. It's like an enumeration in Python. All right. Append. Built-in function to use a dynamic add elements. Okay. We've been asked to add a feature that extracts cost for a given day. Complete the get day cost function using the append function. Accepts a slice of cost structs and a day int and returns a 64. We've been asked to add a feature that extracts cost for a given day. It accepts a slice as cost. Containing that day's cost. Just how do I calculate the? Oh wait, cost is a float. Return an empty slice. Okay, it's fine. Wait, cost dot what? What do I add in this thing? Value? Ah, that's for the value. Cost. Oh yeah, what am I day? Oh. So like if you're saying if c dot day equal day, then add that. Is that what you're trying to say? What? I'm getting just zeros. And I'm just adding to. Yeah, okay. I just realized of size 0. Can I do that? Yeah, okay. Or I could just like, what if I just not size 0, like I could do like this. I don't know how else. Instead of make, let's do this way. Like that. And then how's that? Exactly. Okay, we'll do that. That way is also another way. Range. If there's any bad words in the message, you return the index of the. Oh wait, how to check if an element is in a slice? Go. Okay. Contains. Okay. Take this here, push that here. For every bad words dot contains let's see this contains how do I check if how to check if a value is in a slice? Okay. Let's write it. Func contains the list bad words string word string for every word in range of bad words. Okay, I think that works. Slices of slice. Okay. Let's make this here. So what am I doing? And for every for I equals 0, I is less than rows, I plus plus, for j is less than calls, j plus plus, is that how it works? Okay, the first row, I think I'm gonna just add should I just do that? Where it takes a number of rows and columns and returns a 2D slice of interest. So where I just are the indexes of the row and column respectively. Maybe I should do a counter. So I could do something like this, like matrix, or not matrix. It's like a multiplier. It's like a feed, like a some kind of a multiplier here, right? So like, for example, I would have to multiply it by this 1. So it's always going to do 1 through 9, or 1 through, like, essentially 1 through column, right? Always going to do 1 through col, right? But times, right? Right, so like, Looks like a matrix. Over here, matrix equal append matrix like one row, or like one row, so it's like empty list, and then matrix at I dot equal append matrix J found what? Why can I do this? This is so ridiculous. What am I missing? Expected type. What is it? How do you put an empty list? Put an empty list. Slice in. Go. Oh, I have to specify the type. This is int, like that, right? No, just array of slices. But what is the data type for slice? How do I initialize a slice? Hold on. Instead of initializing, I'll initialize like this int. Oh my god, I have to do this. And then what do I put here? What is this like a, does this have space here? Int. Wait, what do I? Okay. How am I supposed to? Okay. Oh yeah, I forgot. It by default it's gonna. Okay, I got it. I see. I can just slice. I don't need to do this. It's gonna do. Hopefully, it makes zeros. I could just do this, right? Matrix I J equals J times like, so the pattern here is just this is 0 1 2 3, it multiplies by 3, like this is 0 1 2. Yep, yeah. which I don't need a times. I could just say I times j. So if it's, right, for example, I times j, right? Because, right, this is the 0th row. Yeah, this is the first row. Oh yeah, I got it. Oh crap. Oh wait. Why are we out of range? Rows. Wait, what? Call, yeah, I should do calls. How am I out of range? Where am I doing this? What is out of range? Index out of range with links. Oh. Oh, maybe this doesn't zero. Okay, if I do this instead, make make int or I don't know how to do this. This is so really weird. So when I create a slice like this, right? Right? I can't access this. I can't do this. Because there's nothing in the list, right? So do I do this? And then do this? Oh my god. Do that. Then I times that. How am I out of range? I have values. Well, why am I gotta do append. So I have to do it. No, I should do it like this then. So value should be I times j, but I need to make a list first. Append the matrix to an empty list. How do I make an empty list? Append an empty list go. Like append an empty list to an empty slice to another slice. I can't do like I don't know how to add more lists to a list. Can I not do that? Add a list to a list. How to add a slice to a slice. Go. That's my issue. So like this one has, right? The type is an int. I have no idea what's going on. I can't figure this out. It's not append. At this value. Like, I am so confused why I can't figure this out. Adds to the list. But what if I want to add a freaking... Okay, hold on. Do I have to make a damn freaking list again? Like a row. Row. And append row here? Append. This is how you do it. Oh my god. How am I going out of range? That makes no sense. It's ridiculous, bro. I'm so lost. Why is this not clear? Am I not iterating correctly? Right, I can go through rows many times. I can go J column many times, right? At the matrix I, at column J. Hold on. Why this is not valid? Index out of range with length 0. Alright, let me read the test. Which test did it fail? How am I going out of range? It literally does not make a single sense. So I is less than rows, J is less than calls. I don't know. It's stupid. Just think a little straighter, please. Okay, I gotta ask this. What does this mean? Like, this is the last ChatGPT. What is this? So does this initialize stuff with empty list and zeros? No, it doesn't. So I have to add the stuff. Oh, I can use make instead. Oh, is that the type? Okay. Oh, okay. Ah, I can just... Yeah, I can make the rows right now. Right? Then I can make... What would be the better dynamic way to do it? What would be the better dynamic way to do it? Make it... Okay, then let's do this. So we make the thing for every row range of matrix for every call call this row or like I guess. Then for every matrix I make int I mean this is I, right? Then for every let's call this for every I less than I is less than rows I plus plus for j j is less than calls j plus plus matrix at I j equals I times j. So what is this syntax here? Oh, wait. So what is this? What does this do then? So row is not a slice, is a slice. And empty slices of int slices. So if this is a slice that I have to append to this, then I can do this in one go, right? If I initialize it like this, right, matrix is this. Right? The Yep. So I can do essentially for every essentially this stuff right here, right? I can't do this syntax per se. I need to do this create this many rows. So matrix equal append row. Matrix equal append equal row. And I input the content. But I gotta do this after I create a column, or basically build out the row. So row equals append I times j, and then I can put row. I can say matrix. First art. Oh yeah. Row. Would this work? Yeah, this is kind of what I was going for. Damn, this is very different logic right here. Like I wouldn't have thought of, like, this is very thinking, because my Python brain is kicking in, right? Because I could just append a list, you know? But I have to create it, add it to it. You know? It's like, it's kind of weird. I don't know. I'm thinking very differently. I don't know. Maybe I was overthinking, but I think that's it for today. The running video's long. I'll probably do this on my own time. But yeah. Thanks for watching. I'll see you for day 18, as today was day 17. Let me know what else you guys want me to code up and stuff. Maybe like I would love to see anybody's input and stuff. But either way, thanks for watching. I'll see you for tomorrow's video.